to find equation of projectile, let's make the same graph. This is x and y axis, and the particle is projected with initial velocity u, and the path followed by this projectile is this. So we have to establish a relation that this projectile is undergoing a parabolic path, right? So at any instant t, what we are supposing, okay, let's write down the values which we already know. This is, if it is projected at an angle theta, the horizontal component of this velocity would be u cos of theta, and this would be u sin of theta, right? This is the maximum height, but we are not requiring this thing, and this is the range of the projectile, just for the information. What we want is, we have to establish a relation that this projectile is undergoing a parabolic path. For that, what we are doing, consider the position of this projectile particle at any time t be here, right? So suppose it has covered this much distance vertically and this much distance horizontally. I could draw the same thing here, right? So this is the horizontal distance covered by the object, let us say this is x. This is vertical distance covered by the object, let us say y. So the coordinates of this particular point would be x comma y, right? Now, what I am doing right now is, I am just writing a relation for x and y. So I am writing the equation in general, right? I'll be using the same equation, that is displacement time relation, s is equal to ut plus half at square. What we have considered for this particular projectile particle is that in particular time t, it has reached this point whose coordinates are x comma y, that means horizontal distance is x. So if I use all these values for x axis, horizontal distance covered is x, which is equal to ux. Ux is initial velocity along x axis, u cos of theta into t, plus, should I say it again, no oscillation, 0. So because there is no oscillation along x axis, right? So this term is 0. So we are left with only u cos of theta into t. Now, same way, same formula, sy is equal to uy t plus half ay t square. Now I am writing the same equation of motion for the vertical direction, that is y axis. So sy, this is the displacement or distance covered by the projectile particle in y axis. This will become y. This is equal to uy. What is uy? It is initial velocity along y axis. This is u sin of theta into t plus half oscillation along y axis is negative of g because object is going upward. So this is minus of g. So I am removing the complexity here. What I am doing is, I am removing negative sign here and putting it here. Done. So I am left with minus half gt square. So what should be value of t to be placed here? From this equation, we get t is equal to x upon u cos of theta. Put this value of t in this equation, we will get a relation between y and x. Y is equal to u sin of theta into t, which is x upon u cos of theta minus half g t square. This is x upon u cos of theta whole square, right? U cancels out. I am left with x into sin theta upon cos theta, which is tan theta. So y is equal to x tan theta minus half, these are the constant, half g upon u square cos square theta. So I am writing it like this, g over 2 u square cos square theta whole into this is constant into x square. So see this equation, when we already know from the maths that when y is somewhere related with x square, the equation is parabolic in path, right? So this equation represents the equation of trajectory, or this is called path, the equation of trajectory. Trajectory means the path followed by the projectile particle. This is the equation for projectile, and this equation where y is proportional to x square represents that the path followed is parabolic in nature. So you can note it down.